What's up my friends, welcome back to another monthly news. So let's see what you will see in this video, so what we have new this month. First I will talk about the project that I'm recording right now. Actually is a theory video about CFLs, and I will show you the electronic ballast, the components, and using animations. I'll try to explain you how it works, and probably I will post this maybe in 2 weeks. I'm not sure yet because I'm not sure when I will finish this video neither. Anyway, at the end of the next week we will have another Arduino 101 tutorial. So I'll show you how to use the port manipulation and the port register control. I will also show you a new project that I'm working on with a 3D printed helmet from Daft Punk, but this is the second helmet. Also, we'll talk about this huge LED and the project that I'm working on for a projector using that LED or maybe another smaller one. And also, I will show you another future project related to a pellet extruder. I will explain you what it is and the components that we have, and probably some materials that I have here in my workshop and maybe something interesting. So stay tuned, let's see the intro and let's get started. What's up my friends, welcome back. I was just recording a theory video for maybe 2 or 3 weeks because I'm not sure when I will finish this. And this will be related with this. This is a so-called CFL or compact fluorescent light bulb. We have this light bulb and we also have the typical neon tube. Anyway, let me just tell you a small preview about what you will see in that video. We'll make the difference between the ballast coil and the starter configuration, and then I'll explain you the compact version, which is the electronic ballast. The idea goes like this. Inside of this tube we have mercury vapor, and when we strike this with electrons, the mercury atom will radiate UV light, which is not good for us because the UV light will give us cancer. Anyway, we have coated this tube with phosphor. So when that UV radiation inside of the tube will hit the phosphor, this will radiate a visible light, which is the white light that you can see. So in that video, I'll explain you the physics inside of the tube, but also how we can create that current flow of electrons that will hit the mercury vapor. Because for that we need a huge voltage across the tube in order to create that current flow. So for that we use these two components, which is the coil ballast and the starter, and this is very interesting. I'll try to put on the screen some video footage with a slow motion inside of this component and how it works. But the basic idea goes like this. When you first connect 220 volts across this, there is not enough power to create that current flow. So for that we use this starter. When this starter, inside of this starter we have vacuum, and the metal connectors are very close to each other. And that is enough for the 220 volts to create some plasma arcs. Those plasma arcs will heat up the metals and will bend them and touch each other. So when the metals connectors will touch, they will close the circuit, and a lot of current will pass through the neon tube and through the ballast. And this is just a coil with a ferromagnetic or a metal core inside. So that huge current spike will create a huge magnetic field inside this. But after some milliseconds, those metal connectors inside of the starter will get cold and they will separate. And when the circuit is open, the magnetic field inside of the coil will collapse, and that will create a huge voltage spike, maybe of 1000 volts, and that is enough to create a current path inside of the tube. And that current path will hit the mercury, which will create UV radiation, which will hit the phosphor inside and create the light. Once we have that current path open, then the 220 volts, it's enough to keep that current path going on and on. So that's pretty much how this works. I'll explain that in the video, and then I'll explain you the circuit of the compact version, the electronic version of the ballast, how we have the rectifier, then the inverter, the transformer and the coil at the output, the high frequency and so on, and how we connect that to the electrodes inside, what we have inside of a fluorescent tube and so on. So I hope that will be interesting. If you want to see all the components on this PCB, stay tuned, and maybe in 2 or 3 weeks you will have that video. So let's see what more we have in this monthly update. Hey guys, I wanted to make an update about the project that I'm making tests right now, and that is a homemade projector. Here I have some components that I will show you in a few moments. And this project is because I saw a video on a channel that is called DIY Perks. I'm pretty sure that you know that channel. And he made a great projector, which is actually 4K, using a smartphone, an LED, very bright LED, some lenses and so on. So I thought that I should try it myself to make one and maybe post the video and the process on YouTube. Maybe it will be interesting for you. So let me just talk about the components that I have for now for the tests. I have some LED options, This is a 200 watts one, this is a 100 watts one, and as you can see, this is like 10 times or 20 times smaller, but even so, this one, this small LED, is 100 watts. And we'll test this in a moment, and you will see how bright it is. Then we have the Fresnel lenses, we have the screen, which I will use just a normal LCD from a smartphone. We will have another Fresnel lens, the mirror, which is very important, and the final lens, which I will try to use a lens from an old camera. So let me just show these components with more details and test this huge LED and explain a little bit the difference between the big one and the small one. Before I show you the process of the projector, how it will work, how to convert the light into images and then project that with some lenses, let me just make a test with this huge LED. As you can see, this is connected to 220 volts, so this might be a little bit dangerous. And also, as you can see, it's like 20 centimeters long by maybe 10 centimeters wide. So let me just make a test. I'm not sure if you will be able to notice the huge light, the powerful light from here in the camera, because it has auto exposure. But anyway, let me just make a test. And I can't really watch it because it will blind me. I'm not sure if you can see the powerful light, but it is very, very bright. This is actually 200 watts, and that is a very powerful LED. It's huge, it has a matrix inside. And here I have another LED, and this is 100 watts. But as you can see, it's maybe 20 times smaller than the other one. The difference is that this is using AC, 220 volts, this is using DC, and the matrix is a lot smaller, and it will need a lot of heat dissipation because this will get very, very hot. So we need to use a huge cooler to keep it very cool, otherwise it will burn in just a few seconds. Let me just test this once again. Let me just see if I can point it to you, to the camera. Not sure, just put the banana here. Let's test it now. There you have it. This is like having the sun in your room. It's very bright. I just watched it for a few seconds and now I have a lot of spots. Let me just record one more time, like a direct shot at the LED when it's turned on. Let me just turn it on. Not sure if you can see this, but it is very, very bright. Anyway, let me explain you all the components that I have for now and how I'll plan to make this and how usually a projector works. Okay, so the idea for a projector is that we first need a light source, which I'm not sure if I will use this one, which is the problem with this one is that it's using direct high voltage, 220 volts, and also it's quite big, so I will have to make the case a little bit bigger. And the bigger the LED, the light source is, the bigger will have to be the aperture of the lens, and also the bigger will be the distance between the light and the lens, and then the Fresnel lens. Anyway, maybe I'll use this one, which is a lot smaller, but this is using 24 volts DC. This is 100 watts and this is 200 watts. With this, the picture will be a lot brighter, but with this, I think this will be a lot easier to use. Anyway, we'll need a lot of heat dissipation for these two, because they will get very, very hot. So maybe I'll use a PC cooler with a fan or something like that. Then, this light will be bursted in all the directions. So for that, we use a Fresnel lens to make the light go just in one direction, perpendicular to the screen. In that way, you make sure that all the light from here will go straight into the display. As you can see here, you have to take the protection on the back, and then you will make it a transparent screen, as we have seen in the previous weekly update. So that will be some sort of transparent, but some light will be able to pass. So this powerful light will pass through the screen, will get the color from the pixels of the screen, and then using another Fresnel lens, we can project that and focus it into this camera lens. And then using a special type of mirror, this is a one-face mirror or something like that, front-face mirror. So the material that is reflecting is on the top side, so the light doesn't have to pass through the glass and then get out, because that will create a lot of diffraction problems. And then you just project that image on the wall. So we have the light, we project the light straight forward, we pass that light through the screen and get the color of the pixels, we focus the light back into the lens, and with this we project it to the wall. And that's it, how the projector should work. And in order to get the pictures, I will use a smartphone with an Android application and play videos, internet, and so on. So guys, I hope using this huge LED will be interesting for making a projector. I've used this for like 3 minutes ago for just a few seconds and it's still hot. So imagine that, we'll have to use a lot of heat dissipation. Anyway, stay tuned for that project. Maybe I will finish it in 1 or 2 months, I'm not sure, because I have to make a lot of tests and build the entire frame, which will be very difficult for me. But anyway, stay tuned for that, and maybe I'll post more tests in the monthly update soon. What's up, my friends? Welcome back. Just kidding. Do you remember this project? This is the Daft Punk Helmet. This is the Thomas Helmet. Anyway, this was a great project. You can control the LEDs with your smartphone. You have a microphone inside. You can control this with Bluetooth. And it was pretty cool to make it. But now I'm making, you know that Daft Punk, you have Thomas and then you have Manuel. So now I'm making the other helmet. This is what I have till now. In a moment I will show the design on my PC. But anyway, I've designed this in such a way to print it all in one using a 300 by 300 3D printer. But the problem was that the filament just had an error, so the nozzle was clogged. So I had to stop the entire print. So what I've then made was cut the helmet in half, and now I'm printing the other half, and then I'll try to glue them to sand it and make it look a lot better. The problem with this helmet is that it has a huge visor which has to be black but see-through, because you have to see from inside, but from the outside it has to be black. So what I'm thinking is to maybe 3D print the shape, then I will buy some plexiglass, very thin plexiglass, maybe 1 millimeter or 2, using the heat gun, give the shape of the 3D printed part, and then we'll have the visor which will be transparent. And then what I want to use is this kind of film. This is the same kind of film that I use for the see-through mirror, but instead of being shiny, I will use a black. This is the kind of film that you usually use for those tinted window for cars. So in that way, from the outside, it will look like a mirror or maybe black, but from the inside, you'll be able to see. So for the electronics, we'll have a lot of LEDs on the side. We'll have the microphone inside, we'll have the Bluetooth connection, and then the visor will be see-through but black from the outside. So let me just show the other print. This is a print for like 25 hours, and if you were to print the entire case, the entire helmet, it will be like maybe 50 hours. So guys, I think this is the first time that I'm showing you this. This is my desk, and this is where I edit all my parts, my PCBs, and my videos. Right now I'm in After Effects. As you can see, I'm editing the video about the CFL light bulbs. I'm making the animations. If you want to see more, just comment below and I will show you everything that I have on my desk, what computer am I using, what screens, what graphics card, and so on. Anyway, right now I'm in Blender and I wanted to show you the design of the helmet and explain you a little bit how I will make it. Okay, so first let me talk about the visor of the helmet. As you can see, it's quite big. So my idea is to print this using any color of PLA material, maybe black or gray, anyway, it doesn't matter the color, because what I will use this is for support for the plexiglass. So the idea is once I have this part 3D printed, I will place the plexiglass on top of the part, and then using the heat gun, I will give the shape of the plexiglass the same as this one. So then I will have the visor with transparent plexiglass, and then I will place on top of that the film which from the outside will look like black, but from the inside it will be see-through. And as you can see, the rest of the helmet, this is just one part, but in my case I had to stop the print and cut it in half, and then print the top part, and then I will glue them together. And then we have this front part, which will be here in front of the mouth. And the electronics inside, as I told you, we'll have some LEDs on the side with some colored covers, the same that Daft Punk Helmet has. And then we have the microphone, the Bluetooth module, the Arduino, a battery charger, and I'm not sure what more, but we'll see that well in a few weeks when we'll have the case. So here I have the printer making the top part of the helmet, and then I will glue this together because the filament got stuck, the nozzle got clogged, so I have to stop the entire print, and it was going like 20 or 25 hours, because the total print, if you want to print it all in one, is around 40-45 hours. So guys, I also told you that we will talk about the so-called Pellet Extruder, which is an extruder for 3D printers, but instead of using filament, I will use some pellets of PLA, but instead of buying this, the idea is to just recycle my parts. So using a grinder or a shredder, I will shred all the parts, making very small, like 1 or 2 millimeters grains, and then I will use this component that I want to build to print once again another part. So the idea is to, if you have a part that you 3D printed that is not good, you recycle it, you make the grains, and then using this pellet extruder you can print directly with pellets. So you can buy this, and there are some YouTube channels that made this. I'll place that channel below. And that channel made some sort of pellet extruder, but in my case I found this. This is the most important part of this project. As you can see, this is a metal hopper and the rod, and this is a special rod. As you can see, as you go up, it will get more and more thick, and in that way the pressure at the tip will be higher. So the idea is that you place the grains here, and this will push the metal out, will push the plastic outside. And then using these aluminum parts, I want to create my own heated block. I'll place some heaters like this one. This is a normal 12 volts or 24 volts heater from a printer. I'll place that inside of the block. I will heat this entire nozzle, and then with a direct 4mm nozzle like this one from any other printer. As you can see, I'll use this type of nozzles on the outside, and using a stepper motor with a gear I can spin this, and you can extrude directly the material on the table of the printer. So instead of using filament, the idea is to use directly the pellets. So I don't have the design yet. I have something designed on my PC, but it's not finished. The idea is that I have to merge this like this together, the motor with the rod, and then make the heated block on the outside, the thermocouple to read the temperature, or maybe just a resistor to measure the temperature, which is called thermistor, I think. Yes, a thermistor, the heater inside, and then the rest of the parts in order to be able to screw this in place on any printer, because as you can see, this will be quite long, because you have the motor, you have the rod and the nozzle. This will be like maybe 20 centimeters, so I have to make some sort of support to be able to place it on the printer. So yes, I will be making tests for this month, and I'm not sure when it will be ready, but the idea of recycling my own parts is awesome. So I hope that this will be ready soon. One new thing that I have here in my workshop is this new tweezers multimeter that I just received from eDesign. So actually, this is a very practical tool. You just get a component with the tweezer, and it could tell you resistance, voltage across the two terminals, inductance, capacitance. You can also test for short circuits and so on. This is very useful. I will maybe place a link below if you want to buy this. This is the new product from eDesign. Okay, so let me just show you how it works. I have here some SMD resistors of 1K. Let me just measure it. Not sure if you can see it. 932 ohms, which is pretty close to this, but anyway, this is inside of a circuit, so I'm not sure if this is connected in parallel with any other. But anyway, as you can see, you can set it to resistance, and it has here a capacitive button. You can change it, capacitance, inductance, frequency, volts from millivolts up to, I'm not sure the maximum voltage, resistance, and I think this is a short circuit. Not sure if it beeps. Anyway, this is pretty interesting. As you can see, you have to calibrate it. Keep close, open tips, keep open. Save the data, yes. And this also has a signal generator. I'm not sure how to enter. Identify, signal generator, sine wave, calibration. So by touching these buttons here, you can identify, signal generator, noise, user, pulse. You can create the pulse, the signal generator. Anyway, this is very interesting tool. And by the way, it has an accelerometer inside, because if you turn it, it will automatically change the screen. As you can see, you have the text vertically, and then if you spin it, you rotate it, it will automatically adjust the screen if you're left-handed or right-handed. And by the way, you can separate this, and this you have to charge it using the USB connector that they give you. You connect this, and then here you connect the USB Type-C and you charge it. Anyway, I think this is pretty interesting and is very small. Okay guys, the last part that I want to show you for this monthly update are some new wires that I just bought, and this is solid wire that I will use for breadboard connections. And I bought this kind of wire because I usually use this one, which is a little bit thinner, and you can buy this in a set with all the lengths for all the connections for the breadboard. But I don't like this kind of wire because it's very thin, and if you want to use this to peel the plastic off, it will be very fragile and it will break. So that's why you pay maybe $1 or $2 more and you get a thicker wire. And this is made out of copper, which will have better conductivity, and it is a lot better. So I really recommend you to invest in just a few colors of this if you want to have very good breadboard connections and very well organized, because you can cut this to size and then use it on your breadboard. So let me just show you a little bit what I mean by this is very fragile. So here I have the wires that I just bought. These are copper wires and a little bit thicker, and I will use this for all my breadboard connections. As I told you, I usually use these thin wires, and you can buy a set of this, but the problems of this is they are very sensible. As you can see, very fragile. If I want to peel one, so I peel it, but now look, just move it a little bit and it will break. So if you want to use this on your breadboard, you will maybe just place it 2 or 3 times and then it will break. So that's why I bought these wires. These are a little bit thicker, and as you can see are made out of copper. So the conductivity is a lot better because this is not copper. This is just some thin metal. I'm not sure what kind of metal this is, but these are a lot better. You pay a little bit of extra money, maybe $1 or $2 more, but you get these very nice wires that you can cut to size and then use it for your breadboards. And I bought 4 colors because you have to make the power connection with black and red, and then some signal connections with this one. So yes, I have a bunch of these thin wires from old projects, but these are not good at all. You can usually buy this in a set of all the lengths, but as you can see, look how easy it is to break it. If you want to peel it, it will break. It's very, very difficult to clean the wire. And now it's very fragile. Just move it a little bit and it will break. Anyway, I hope that you find this interesting. So guys, that was the monthly update. We have seen the Projector project with the huge LED. I've shown you the future project with the Pellet Extruder. I've explained you how the CFL light bulb works and what you will see in the future project. And by the way, at the end of this week or the next week, you'll also see another Arduino theory video about port manipulation with registers. And we have also seen the new Daft Punk project, the 3D printed project. So I hope that this will be interesting for you. So keep up, stay tuned for the next videos, and I will see you next time. Keep up, you guys. Hey guys, ElectroNews here. This video just ended. I hope that you enjoyed it and that you have learned something new. And thank you very much for subscribing, and maybe leave a like to this video and also activate the notification bell. And a huge thank you to our patrons, because as you know, I buy a lot of modules, components for my project. So with your help on Patreon, I'll be able to have more time and more money to invest into this kind of projects and keep these videos going and going. So once again, thank you very much to all my patrons. If you want to support me as well, you have the link below. And if you can support me on Patreon, just subscribe to this channel, maybe follow me on Instagram, on Facebook, and join the community on electronews.io.